In this lesson, we will talk about cloud computing architecture. First, I will talk about server virtualization and virtual switches, then we will end our lesson by talking about physical data centers and cloud computing services. On this page, let's talk about server virtualization first. When you look at the figure here, you can see a classic server. You can use it by installing the operating system and the applications you use on this server. In our classic server, we have a hard disk, a CPU, a RAM and a network card. We install the Windows Server operating system or Linux operating system and the applications we use on these hardware. As an example, we use it by installing an accounting program, ERP program, CRM programs or various applications. When we look at the figure here, it shows server virtualization. We have one physical server here again. This physical server has a hard disk, CPU, RAMs and network interface card. Here, instead of the operating system, we install a virtualization software that we define as hypervisor. On top of this virtualization software, we create virtual machines by installing Windows Server 2016, Windows Server 2012, Windows 7, Windows 10 or Linux operating systems. After creating virtual machines, we can install different applications on these virtual machines. First we install a hypervisor software on our physical server, and then we can create virtual machines by installing different operating systems through this hypervisor software. Here we have only one operating system on our physical server. By installing hypervisor software on the physical server here, we can use it by creating different virtual machines and installing operating systems. Now, I would like to show the VMware ESXi hypervisor interface that we have installed on this server and briefly explain how we create virtual machines and install operating systems on VMware ESXi. I connected to the graphical user interface of the VMware ESXi hypervisor software that we installed on our physical server. We can use this software by creating virtual machines on it. You can install the operating system you want on the virtual machines we have created. You can install Windows Server, Windows 10 or Linux. You can use it by installing operating systems according to your needs and installing your applications on these operating systems. Today's data centers work this way. They serve us by installing virtualization software on physical servers and installing virtual machines on virtualization software. You can see our virtual machines here. When we look at the virtual machines here, you can see that I have installed one Windows Server 2016 and two Windows 10. I named it as Server 1 and these as Client 1 and Client 2. When you look at the storage page here, you can see the hard disks on your physical server. You can connect them here in external storage. Since I am in the lab environment right now, I do not need an external storage. I am using the hard disks on the server. I have one SSD hard disk, I have two SAS and one SATA hard disk. Here, we create virtual switches so that virtual machines on the hypervisor can connect. We only have one virtual switch at the moment. Let's look at this switch. This port you see here is our port connecting to the physical switch. Our switch here is a virtual switch. By connecting the virtual machines on the ESXi hypervisor to this switch, we enable them to access the physical network from here. We can create VLAN groups on this virtual switch as you can see here. For example, here we have VLAN 10 group and there is server 1 in this group. Apart from that, you can see that there are VLAN 10, VLAN 20 and VLAN 30 groups on this switch. You can see that there is Client 1 in VLAN 20 and Client 2 in VLAN 30. Here, you can create a second virtual switch if you want. In order to create the second switch, the second physical port of your server must be connected to the physical switch. Currently, we can only create one virtual switch, since we have only one physical connection. If you have a second physical connection, you can create a second virtual switch, or you can connect the second port to this switch and provide redundancy. Now let's go back to our slide and continue with our topics. As we mentioned in the ESXi hypervisor interface, we can now use more than one server on a physical server by installing virtualization platforms on our physical servers in data centers and installing operating systems on these virtualization software. In this way, we virtualize our servers and use hardware resources more efficiently. On our page here, we will talk a little more about the virtual switches we mentioned earlier. Here we connect the port from our physical switch to our virtual switch. We can connect one or more. On physical servers, there are usually two network interface cards in default. You can increase these cards if you want. You can make Ether channel by connecting two existing ports on your server to a physical switch, or you can use it as a trunk port. You can get your virtual machines in these VLAN groups by creating VLAN groups on the virtual switch here. You can use virtual switches in this way according to your needs. Let's talk about physical data centers on this page. As you can see here in the physical data center, we have rack cabinets. You can arrange our servers in our rack cabinets from bottom to top or from top to bottom as you wish. In default, there are usually 2 network cards on the servers. We connect these cards to switches, which we call TOR, as you can see here. TOR, an abbreviation for top of rack. By connecting the first of the ports coming from the server here to the first TOR switch and the second to the second TOR switch, we are backing up the network connection of our servers. We connect the connections from TOR switch to end of rack switches here. First TOR switch, we connect the first end of rack switch to the second end of rack switch, and we use our switches as a backup by connecting the second TOR switch to the second end of rack switch. The figure here shows the workflow in a virtualized data center. The customer requests a virtual machine. Our IT team uses the graphical user interface and APIs to create the virtual machine the customer wants by using the virtualization software in the data center. The workflow here also proceeds in this way. In other words, our IT team evaluates the incoming demand, and we fulfill the customer's request by creating the virtual machine on our physical servers in the data center through the interfaces we use. On this page, let's talk about cloud computing services. Cloud computing is a different model of providing IT services. Cloud computing often uses virtualization products, but uses products made specifically for cloud computing. Cloud computing is not just a product line to be applied, instead, it is a way of providing IT services. Now, let's examine private cloud, one of the cloud computing services, also called on-premise. To create a private cloud, an organization often modifies its internal workflow processes using virtualization tools. For example, imagine an application developer in a company needs virtual machines to use while developing an application. The application developer may want these virtual machines to start automatically and be available within minutes. For this process to work, the cloud team needs to add some tools and processes to the virtualized data center. For example, it installs software to create the Cloud Services Interface Catalog with APIs for both the user interface and virtualization systems. This interface software can react according to user requests, for example, using virtualization software with APIs to add, migrate or create virtual machines. In addition, a cloud team of server, virtualization and network engineers can gather user statistics via APIs to test and add new services in the user interface and make updates accordingly. The figure here shows the workflow in private cloud. Similar to the workflow we talked about on the previous page, the workflow proceeds in the same way here. Generally, large holding companies and banks use the private cloud structure. They create their own data centers and enable their other companies or branches to use it by creating virtual servers from the data center here. For example, if the software development team in a bank wants a virtual server, the friends in the IT team here meet the demand of the team here by creating the virtual machine that the software development team needs by using the graphical user interface and APIs. The workflow here also takes place as shown in the figure. On this page, let's talk about public cloud. In private cloud, the cloud provider and cloud user are part of the same company. In the public cloud, the opposite is true. The public cloud provider sells all services to all users and all companies. The figure here also shows the public cloud workflow. 3 common service models are used in the public cloud today. The first is infrastructure as a service, the second is software as a service, and the third is platform as a service. First, let's talk briefly about infrastructure as a service. Here, the customer determines the features of the server according to his own needs, hosts the server in the data center of the service provider, installs the operating system and applications he wants to use on it and starts using the server. The second widely used method is software as a service. In this method, the company that provides the cloud computing service determines the hardware and operating system itself. We only use the application we purchased on this server. Here's a look at platform as a service. Platform as a service logic is also similar to infrastructure as a service. In infrastructure as a service, the customer chooses the hardware of the server himself. Here the hardware of the servers is determined by the service provider. You use the server by making your selection according to the hardware determined by the service provider. Today, these 3 models are widely used in cloud computing. In this lesson, we briefly talked about cloud computing architecture. See you in our next lesson.